Okay, so today what we're going to talk about is we're going to talk about distributions and their shapes. So basically what this module is going to be going into statistics. So introduction to this lesson. So statistics is all about some kind of data that we will have. Without any data to talk about or to analyze or to question, statistics would not exist. There is a story to be uncovered behind all the data, a story that has characters, plots, and problems. So, the questions or problems addressed by the data and their stories can be disappointing, exciting, or just plain ordinary. Okay? This module is about stories that begin with data. So to begin with data, today we're going to talk about the different types of graphs that we have. So, the first example is all about the graphs. So looking at this, data are often summarized by graphs. The graphs are the first indicator of variability in the data, or variance in the data. So, if we were looking at this, the first one is dot plots. A dot plot is a plot of each data value on a scale of a number line. So if we have something like this number line down here, and we have all these dots on here, we have dots at specific numbers. So that would mean that there are 3 10s in our data set, or 2 20s. Or here, if we look at about 71, there's all these. What are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 at 71. So that's how many 71s that we have, and so on. The next type of graph that we're going to talk about is a histogram. In a histogram, so a histogram is kind of similar to a bar graph, but there's differences. Because in a bar graph, it doesn't matter the width of each bar. In this case, in a histogram is a graph of data that groups the data based on intervals and represents the data in each interval by a bar. Each one of these bars in a histogram has to be the same size. So let's write that down. So all bars must be the same width. So each one of these bars has to be the same width. That's the difference between a histogram and a bargram. That's one difference. And, again, with any graph, you have to make sure that you're going up by the same intervals. So in this graph, we must have the same intervals. Or we could say that we have to go up by the same amount. Okay? So let's move on to our next type of graph. The next type of graph is called a box plot, or some of you may have known this as a box and whisker plot. Okay? So with a box and whisker plot, it's a graph that provides a picture of the data ordered and divided into 4 intervals that each contain approximately 25% of the data. So basically, the dot down here, this is going to be your lowest value. And your furthest point all the way over here is going to be your highest value. Okay? And then it says it breaks it up, so each one is 25%. So each section, so down here would be 25%. This first interval would be 25%. This would be 25%, and then this interval all down here would represent 25% of the data. Yes, I understand that if we look at this, each interval here, so each section, is not the same width. But that doesn't matter. That just represents some number. Okay? So looking at this, we can see that this box in your box plot will always represent 50% of your data, because 25 plus 25 is 50. Okay? So this whole section right here, for your box, will always represent 50% of your data. Well, whatever your data is. Some kind of data that we are trying to figure out. Okay? In this case, they have number of pets. So that's 50% of the people, we could say, have pets between 1 in 5. So they have 1 to 5 pets. 50% of whoever we interviewed, wherever we're getting this data from, 50% of these people have at least 1 to 5 pets. Okay? So now let's look into analyzing some of these graphs. So let's look at exercise 1. Exercise 1 says transportation officials collect data on flight delays. So it's the number of minutes past the scheduled departure time that a flight takes off. So if we're looking at this, they want us to consider the dot plot of the delay time for 60 Big Air flights. So Big Air flights is the airline that they're talking about. And then it was during December 2012. So they have all these dots on this number line here. So the first question says, what do you think this graph is telling us about the flight delays of the 60 flights? So if we look at this, we have to look to see what time in minutes is the most amount of delay time. And if we look at this, about here, this section right here is the one that has the most delay times. And that would be at about 15. So this would be about 15, because it's halfway between 10 and 20. So what could that tell us? That would tell us that most flights are delayed "15 minutes. Okay. And then if we look at this, most of our data is kind of to the left of the graph. So we have like the middle of the graph. Most of our data is kind of to the left. So most of our data is over here. So we can say that the data is skewed left. Okay. So we can first say most of our data is to the left on the graph. So that's what we talked about, skewed. Skewed just means that it's not a normal distribution. It's either to the left or most of them will be to the right. So it will be either skewed to the left or skewed to the right. Looking at this, now we want to kind of analyze the situation here. They want to know, can you think of a reason why the data represented by this graph provides important information? If we were talking about delay times in this, we would be talking about if you were going traveling to a different city, maybe on vacation or something. You would want to know what the average delay times were so that you could figure out which airline you want to pick. So that could be one reason why this information is important. So let's write that one down. We could say if flights are late, travelers might not pick this airline. Okay? And the airline that it was is Big Air. Okay? Another thing we want to know is who might be interested in this data, the data that's distribution. So, in this data, who would want to know? Probably people like you and me that want to travel or something. If we wanted to travel somewhere where we'd have to take an airplane, we would want to know what the wait times were so that we could figure out which one has the best wait times so we don't have to wait at the airport. Nobody wants to wait in the airport. So we could say travelers would be interested. Also, maybe the people at Big Air would want to know this so they can figure out why they have all these wait times. And basically anyone could be interested. Okay? We could say would be interested. Because we want to know what the average wait times are, and so on. Now it says, based on your previous work with dot plots, so what we talked about today, or what you've done in 6th, 7th, and 8th grade, if you have done it. If not, we can still go with it. So it says, based on your previous work with dot plots, would you describe the dot plot as representing a symmetric or a skewed data distribution? So remember, a skewed data distribution is not a mound shape. So basically, I'm going to talk about what the normal distribution would look like. I'm going to draw it kind of up here. So this would be the normal distribution. If we're talking about the normal distribution, then all your data kind of goes in a mound shape. So most data is in the middle. Okay, so this would be your mound shape. Okay, so if that's your mound shape, if we look at this, our data doesn't really have a mound shape. Our data is kind of skewed to the left. So that's what we're going to write down here. So looking at this, they want to know, do we have a symmetric or a normal distribution, or do we have a skewed distribution? Here we have a skewed data distribution. And with a skewed data distribution, we can either be skewed to the left or skewed to the right. Here we're kind of skewed, most of our data is to the left. So here we would be skewed left. So that the tail, or they say the tail end, would be on the right. So we'll say skewed to the left with the tail to the right. Okay? So now let's look at our next example. Our next example is a different dot plot. So it says a random sample of 80 viewers of a television show was selected. So we have some television show. Just make up whatever television show you want it to be. The data plot below shows distribution of the ages and years of these 80 viewers. So there's 80 people total that they interviewed for this. So looking at this, they have all their data set right here. All these dots represent one person, however old they are.
Deanna Garwald, would you please come to the main office? Deanna Garwald, please come to the main office.
So, looking at this, they want to know, what do you think this graph is telling us about the ages of the 80 viewers in the sample? So basically we want to look for which one has the most data. The most data is all right here. This is where most of the data is. So if most data is all the way to the right, what we have here is that if we're looking at some television show, the most popular age group for this television show would be somewhere between 60 and 75. Okay? So we could say the typical age group for viewers of this TV show, or we could say of this show, is, we could say ranges between about probably 60 to 70, or 75 we could say. I'm going to say between 60 to 70 years old. That's where most of our data is. So it must be some show for people between the ages of 60 to 70. That's the most popular. But it also shows that we have some people that are like 4 or 5 years old and so on that are watching this, 40 to 50. They're watching whatever the show is, they're still watching it. So this data also shows us that the show appeals to a wide range of data, or of ages. So there's a wide range of ages of people that watch this show. Looking at this, can we think of any reasons why the data presented by this graph provides important information? So if we're looking at this, the viewer's age, if we're trying to figure out, maybe with TV shows, they could be sponsors. People could be sponsoring them or giving them money so that they can pull off this data set. Or the people that are actually producing this show would also maybe want to know who are the ages of the people that they're actually making this TV show for. So let's look at this. So what are some important information that we could come? we could say that, first off, this data is important in understanding the audience of the show. Okay, so we're looking at, they want to know how many people watch our show, what ages they are, so it kind of ranges from 0 to 80 years old, around. So looking at this, there would also maybe be sponsors that would want to know this information. So who might be interested in this data distribution? Probably the sponsors for the show, or somebody else who is dealing with the show. So we could say sponsors of the show would be interested in this information. Okay? Or if you can think of anyone else that would be interested, you could write that down in your notes and then share it with us on Monday. So, it says, based on your previous work with dot plots, would you describe this dot plot as representing a symmetric or a skewed data distribution? So remember, a symmetric means that we're going to have that mound curve. So most of our data is going to be in the middle of our graph. So let's go up and look at this. Most of our data is to the right. So then we could say that it's a skewed data set. So we're going to say that it's skewed right. And if it's skewed right, then the tail end of the data, so if it's skewed over here, the tail of our data is going to be to the left. So it's skewed right with the tail to the left. Okay. All right, so let's move on to our next example, our next exercise. So exercise 3. Now we're going to be looking at a histogram. So it says the following histogram represents the age distribution of the population of Kenya in 2010. So looking at this, it says, what do you think this graph is telling us about the population of Kenya? So if we're looking at this, most of our data, or the highest part of our data, would be down here. So we know that most of our data is going to be to the left here. So looking at this, what could this tell us? Well, a large percentage of the population is kind of young. We could kind of assume that from this histogram. So we could say a large percentage of people in Kenya are between probably the ages of 0 and 10. That's where most of our data is, the highest percentage, between 0 and 10 years old. Okay? It could also tell us that there's there's a larger, younger population than there is for older population in Kenya. Because if you look over here, between 60 and 80, there's not that many. There might be 2% or 1% and so on for older people. So basically this is telling us that histogram shows us that the ages of Kenya, most of the people in Kenya are younger rather than older. So we said, why might we want to study the data represented by this graph? So if we look at this, why might we want to study the data? Well, if we look at this, why would someone want to know anything about the ages of people in Kenya? It kind of will tell us about the population. So this might be important for anyone that wants to know about. So it tells us anything about the population. Okay, we could say something about the challenges based on ages. So this could give us some insight on some of the challenges that they have in Kenya based on age. Because it seems like in Kenya, they may want to focus on the education of young people because they have such a large population of young people. So they would want to go through, and we could probably look at education of young people, of younger, we could say younger generation. Okay? And now the last question, it says, based on your previous work with histograms, we have to describe this histogram as representing a symmetrical or a skewed distribution. So remember, a symmetrical would have most of our data would be in the middle of our graph. But in this case, most of our data is to the left. So, looking at this, we could say that it's skewed left. So our data is skewed left. And then if it's skewed left, the tail end is going to be to the right. So it's skewed left, tail to the right. Okay? So now let's move on to our next example. So looking at this, it says the following histogram represents the age distribution of the population in the United States now in 2010. So looking at this, what do you think this graph is telling us about the population in the United States? Well, if we look at this, we can see that between 0, the ages of 0, and about 60 here, we kind of have the same percentage of people that range from 0 to 60. So, what could this tell us? This could tell us that the percentage of population is about the same in age range up until the interval for 60 to 65. That's when it starts to go down, in this interval right here. So in this interval right here is when it starts to decrease. So between 60 and 65. So until the interval for ages 60 to 65. Okay? So then we're looking at this. Why might we want to study this data represented by this graph? So we could look at population data, can be used to determine, we use this for health challenges to see what we have the most amount of people, what age. It could also be for education, just like with Kenya, with education, or even with insurance company. They want to know where do we have, what age group do we have the most people of in the United States. So looking at this, we can say population data can be used to determine, we could be health challenges, so people that would want to be interested in health challenges. You would want to know education challenges. Or maybe for businesses. Businesses such as insurance companies. They would want to know what is the age group that we have the most people of in the United States. And maybe they would cater their insurance more towards the people that we have the most of, the age group. Okay? So let's move on to the next one. Now we're going to move on to a box plot, or a box and whisker plot. So looking at this, it says 30 students from Riverside City High School were asked how many pets they owned. The following box was prepared for their answers. So it says box plot for the number of pets. So this is the number of pets that 30 students from River City High School have. And remember, with box plots, we know that in our box part, or this box right here, This is where 50% of the data is, in this box. So, what could this tell us? So this says, what does this box plot tell us about the number of pets owned by 30 students at River City High School? Well, that could tell us that 50% of the students have between, if we go down to our lowest point, this would be about 1. This would be about 5. So 50% of the students own between 1 and 5 pets. Okay. And then looking at this, why might understanding this data behind this graph be important? Well, if you know how many pets, you could know more about the students. Okay? So we could be the interest of the students. Or maybe at your school you're planning an event for pets, to bring pets in, so you'd want to know how many pets. So that could be another reason why understanding this data. So we could do, if we're planning an event to include pets, that could also be a reason why you'd want to know this information. Okay? And you could always take this information further and then make more graphs on the number of pets or the number of cats that people have, and the number of dogs, and then you'll be able to compare them. So that's basically what all statistics is we're comparing information, or comparing data that we come up with. Okay? So let's look at this last example on the back page. Example 6, or exercise 6. Now they have 22 juniors from River City High School participated in a walkathon to raise money for their school band. The following box plot was constructed using the number of miles walked by each of the 22 juniors. So we know in this class they were raising money for the school band. The juniors were. And there's 22 juniors. So we know that we have 22 in our data. We have 22 data sets. So looking at this, they want to know, looking at this, what do you think this box plot tells us about the number of miles walked by the 22 juniors? So looking at this, we know again that our box plot has 50% of the data, or the box part of it. This would be 50% of the data. And we go down to our lowest point, about 4 to 9. So we know that 50% of the juniors walked 4 to 9 miles. So we could say 50% of juniors walked between 4 to 9 miles. We also can tell that if we look at the lower portion, we know the lower portion represents 25%. So we could say that 25% walked between 0 to 4 miles. And then the last 25% is on the other side. So this would be the last 25%. If we go down, that would be about 11. So we could say that 25% walked between this 9 miles and 11 miles. Okay. And then again, for number 2, the last question says, why might understanding this data behind the graph be important? Well, this might be important because it shows the participation of the junior class in the walkathon. So it could be important because it shows participation of the junior class in the walkathon. And when you have a walkathon, you also have sponsors. You have people that donate money to you for your walk. So those sponsors also might be interested. So sponsors might be interested in the data or in how the juniors participated. Okay? So basically today all we did was go through a general overview of the graphs that we're going to be analyzing and using in this module. And that will be the end of lesson 1 in module 2.